Okay, so now we made it to the next section, making a function call itself. Now, this is a good technique to learn, a good concept definitely to learn, so you can understand how to call a function. So it's serve double duty here. So callback functions, and so going over how this works is really going to add some value to what you're learning. So if you're new to this channel and you would like to follow along with the curriculum, it's free. Click the link in the description and it doesn't cost you anything. So without further ado, let's get into this section. So making a function call itself. Congratulations. Identifying the base case is often the trickiest part of building a recursive function. We made it this far with combined entries. So we have the function combined entries. We're passing in a parameter, and then we're checking the base. This is the base case right here. Notice it doesn't say base case, but we know what it is because we're looking for something to be true so that the function can terminate itself. So now we are ready to take the next step. A visual representation to help visualize what happens during recursions. Let's start with the base case L. So we create the L as the base case, so we return L. Nothing is complicated here. Combined entry sees only one item in the array, so it returns L. Now consider an array with two elements, LC. Combined entries, called combined entries. Separate first entry, check what's left. Return L. Plus combined entries, what's left is C. Before returning the final result, evaluate the new combined entries call. Now the base returns C. The final result is evaluated and returns C. In this case, combined entries execute the else statement. We have no code for this yet, but we can still consider the logic. Combined entries returns L and calls itself again using what is left inside of the array. So it's checking the array to see if anything else is there. When past C, which is the base case, combined entries return C. The string LC gets combined and returned as the final result. Next, consider an array with three elements, LC1. So it goes through the process again. It separates the first entry, then it checks to see what's left, and then it goes ahead and it separates that entry, and then it checks to see what's left. Now what? The base case returns 1. So now 1 is the base case. So you're understanding whatever the last thing in the array for the recursive is considered the base case. So we have to write the code to find the end of the array. Then we get the final results. As before, combined entries executes the else statement and we can follow the logic. Combined entries returns L and calls itself again using what is left inside the array, which is C and 1, string C and 1. When past C and 1, combines entries return C and calls itself again using what is left inside the array. When past 1, which is the base case, combined entries return 1. The string C and 1 gets combined and returned. The strings L and C1 gets combined and returns as the final result. As we make the array longer, combined entries calls itself more times. Each call evaluates a smaller and smaller section of the array until reaching the base case. This sets up a series of return events, each one selecting a single entry from the array. Rather than building LC101 from the left to the right, recursion constructs the string starting with the base case and adding new characters to the front. So basically it gets to the end. The base case is whatever the last array is, or the last item of the array. So that's the base case. Returns the element an array of length 1. And then it combines the first element from an array of length 2 with the base case value. So remember, the 1 is the base case. So we already know what the base case is. Identifying that, this is why we say it's difficult, maybe challenging, because we got to write the code to make sure it finds whatever is at the end, whatever the last item is. Then it keeps combining, and then we get to the length of 3 with 2 previous values. So now we got 101. It combines the first element array of length 4 and then 3 previous values. Now we got C101. Combines the first element from an array of length 5 with 4 previous values. Recursive processes all follow this approach. They all follow this approach. Each call to the function reduces a problem into a slightly smaller piece. The reduction continues until reaching the simplest possible form, the base case. The base case is then solved, and this creates a starting point for completing all of the previous steps. A function calls itself. So how do we code the else statement and combine entries? Recall what needs to happen each time the statement runs. Select the first element in the array. Call combine entries again in a smaller array. Bracket notation takes care of part A, array at 0 index with the bracket notation. For part B, remember that the slice method returns selected entries from an array to return everything but the first entry in array. LC101 uses r.slice1. Understand what the slice method does. Let's add the bracket notation, the slice method, to our function. So here we go. It says return array at 0 index plus combine entries array.slice1. Each time the else statement returns, it extracts the first element in the array with array at index 0. Then it calls itself with the remaining array elements, array.slice1. For combine entries LC101, the sequence will be first call combine L with combine C101, second call combine C with combine entries 101, third call combine 1 with combine entries 01, fourth, and so on and so forth. To get the final results, proceed up the chart. Remember, it's going to start with 1 and it goes all the way down to LC101. So we made it to the end. So check your understanding. Okay, so we made it to the end of this particular section. Again, this actually is something you can use in other concepts as well. So taking your time to kind of get your head wrapped around it. Later on, when we introduce other types of concepts, you know that you've already been introduced to showing you how a function can call itself. And we're going to use that later on in our programming. Now, remember, the more you do, the more you improve. See you in the next section.